Okay, the next topic is kind of a summarization of what we have done in the past 3 years in, trying less dormant alfalfa in the valley. And if you guys can see, it looks like you can see my screen right now. This is funded by the U.S. Department of Agriculture, as well as the Montana Fertilizer Advisory Committee. And I'd like to acknowledge Yusha Nafi, my postdoc here, as my co-author for this presentation. So as a background, there is an evidence that we have slightly longer fall in northwestern Montana in the past, within the decade. It looks like fall is extended a little bit longer, slightly. And we thought that less dormant alfalfa would be something that we have to look at as an option, for the reason that it grows a bit faster in spring relatively than the more dormant alfalfa. Documentation of these under different water and nutrient levels is always a concern. As Jamie mentioned, there's a large proportion of the management and environment that would that crops would respond to, not just genetics, and as well as persistence of these genetics as well. So excuse me for the y-axis here. This is rather not very common units to use, but this is just a relative comparison between an extreme condition, say for instance, Arizona versus Montana. Here is just a cumulative biomass. We sampled very tiny area on the ground, and we sampled it really, really fine in the season, just to monitor why fall dormancy number 6, which is less dormant, would be advantageous in some areas, and fall dormancy number 3, which is more dormant, is not. So in Arizona, for instance, what is common is fall dormancy number 6, the open symbols there. And we heard that farmers there want to try fall dormancy number 3, just because they want to have more quality over yield. On the other hand, in Montana, we especially here in the northwestern Montana, we don't really have much more of a problem in terms of achieving good quality in alfalfa. So the more, I think the more yield is not so much a hindrance for quality there. So when we look at this cumulative biomass, it is natural that fall dormancy number 6 would be over time. This is a span of 2 years, really, 2018 and 2019, that their fall dormancy number 6 there would accumulate much greater yield or accumulated biomass versus the fall dormancy number 3. And you'd be surprised, it's similarly the same in Montana. Fall dormancy number 6 is a little bit higher than fall dormancy number 3, especially on the second year, where in the early spring regrowth there, close to that 390 days after planting, there's an early regrowth there for fall dormancy number 6. Of course, we're relatively lower yield in comparison with Arizona. So this is what I was talking about, and again in this, this is just an expansion for the Montana data here. And the y-axis is accumulated biomass over time. And if you can see here, fall dormancy number 6, in the fall of the first year of establishment in 2018, started to have a better regrowth compared to fall dormancy number 3, which is a rugged. And then this advantageous fast regrowth in fall dormancy number 6 continued early in spring, and then nothing afterwards. So it's not always that it's advantageous. There's just a small window in the fall and in the spring that it shows an advantage. So this is just a quick look at the field here. The greener plot there is the fall dormancy number 6. As you can see, just after cutting it, it grows a little bit faster than others. And that is because when you look at, this is again another area index unit, which is not very common. But what I'm trying to explain it here is that accumulated biomass is due to the expansion of different tissues, for instance, on the leaves and the stems. So as you can see here in the fall, September of 2018, it began there where fall dormancy number 6 have more tissue expansion, and it continued in early spring of the following year. So in the establishment year here in 2018, this is the first year, we have 3 different environments. We have 100% evapotranspiration. We irrigated 10 inches here, and then 50 ET, which is a deficit, we irrigated about 5 inches, and then rain-fed here. So you can see that even though this is not necessarily statistical significant, this is not necessarily too different from each other, but you can see that the fall dormancy number 6, which is the Cisco, for instance, is in the higher range, numerically speaking. And then the Higest, which is another fall dormancy number 6, this is low lignin, is on the lower spectrum, and it's consistent across moisture regime. Higest fall dormancy number 6, low lignin, it could be used for different purpose, not so much on the yield, but perhaps on the quality side. So just a summary of the response of the irrigation here. You can see here to the total to the far right that we applied 10 inches and it only gave us 3.2. And then on the 50 ET, which is the deficit, we irrigated 5 inches and it only gave us 2.6 versus the rain-fed, which is 1.5. And so you can see here in that irrigation productivity that the deficit has more water response there in terms of irrigation water productivity. It's a lot higher than the 100% ET. So just something to think about, that irrigating the plants more than what they need is not necessarily a good thing. It's nothing to say that 50 ET is magical, where you just hold water and plant will just naturally grow fast, but really what it is that it's trying to use the rainfall events within those irrigation events. So for the first, in the 2019, we started seeing that the fall dormancy number 6 Cisco is beginning to show an advantage, but only in the irrigated side, in the deficit and in the full irrigation. Again, the fall dormancy number 6, which is the Higest, is consistently below. And again, another thing is the 50 ET, the deficit, also has high irrigation productivity per inch of water. So that's just something to think about. We applied 6.4 versus 12.7, basically the same irrigation events, but we just split it in half to come up with a 50% ET or a deficit irrigation. So the 6.4 was basically applied approximately 10 times within the season. So on the 2020, on the third year, we find that the advantage of the fall dormancy number 6 Cisco is only numerical. Some of these varieties caught up and they have the same yield as the leading fall dormancy 6 Cisco. And as I said, Higest 660 low lignin is consistently lower. And again, the deficit treatment here for irrigation has higher irrigation water productivity. So we tried another experiment. We put different levels of P and K rates combination on 6 alfalfa dormancy. and also in irrigated and rain-fed environment. So this is rather large a study. And I have to acknowledge Amanda and Landry and the rest of the team for the hard work in this one, because it's not so easy to manage such a large study, and we cut 3 times during the year. So in the establishment year, which is 2019, the response of the different rates of P and K combination was not observed. And that is just normal, because in the first year you would have lower yield and you still have a lot of those residual nutrients in 2019. But in 2020, in 2020, we began to see this effect. As you see here in the control, it had the lowest yield, and the full rates here remained higher yield compared to the lower rates. The forage yield for this study also, as you can see under the irrigated environment, fall dormancy number 6, which again, a Cisco 2, is also the highest amongst the genetics. Whereas here under rain-fed, Cisco 2 only shows numerical advantage, but statistically the same. But most of the effect of the advantage of this less dormant fall dormancy number 6 is very much observed under irrigated environment. So here's the takeaway here. As I said, fall dormancy number 6 Cisco showed competitive advantage based on our 3-year of data gathering for 2 of the locations. Although on the 3rd year, I have to qualify that the Cisco advantage is not anymore as visible on the 3rd year. Again, FD6 advantage has a caveat. Low lignin type high-jest is the least competitive, but should be used for any other purpose other than yield. For 2 years of study, we tried fall dormancy number 7. It probably is crazy to think that why would a Montanan would try fall dormancy number 7, but it persisted with similar yields to most of the FD varieties in the 2nd year. And we would document further on its performance on the 3rd year this year. In general, irrigating using a deficit approach is with much greater irrigation productivity. It is something that we can incorporate in our program to apply more intensity but less amount per event. On the 2nd year, the effect of the P and K rates was starting to get observed, and we are excited to see if we will see a more comprehensive picture on the 3rd year of establishment for this study. With that, I appreciate my team here for making this study successful this year, and also the funding agency, USDA, NIFA, and Montana Fertilizer Advisory Committee. I don't have much time, but I could take a few questions before we can proceed to the next speaker.
Jessica, it's Drake. One just quick question would be, these trials are really great to see fall dormancies. Do you suppose it just has to do with the valley we're in, that we're not seeing like mortality, death rates with those higher, those fall dormancy 6s? Or do you think this is something that you could see even moving to the east side and maybe helping guys plant a fall dormancy 4 instead of a fall dormancy 2, and still see, yields and that kind of stuff given fall dormancies?
Yeah, so that is a very question, Treg. In fact, we anticipated it when we conducted this study, that we have to document some of this performance in other studies. So we did put a trial in Havre. As you know, Havre would have lesser rainfall in July and August than us, or even June. They would have more rainfall in June, but also they're colder too. So we planted full dormancy 2 up to 6 there, no, up to 7, and this variety persisted for 2 years, even 6 and 7. Though we documented though that there's no yield advantage of these because we grow them under rain-fed. And so perhaps what we don't know is if we irrigate this genetics under those environment, we don't know if they would respond just like here in the valley. But yeah, for the second year it persisted. The only problem with a low yielding area like Havre is weeds is going to be extremely difficult to manage. And so at some point this year we are going to abandon it because the yield is just too much, and it's almost unbearable to manually row them. So, but we will probably take photos on the 3rd year just to see persistence, not so much on the actual yield. But thank you for the question. That's a great question, Trey.